We have to remind Jeanette. Jeanette, you better come in the morning and take your quiz. Everyone here loved it. It was really easy, huh, guys?
Yeah.
Don't answer the first
It
question.
was so easy, none of us got 100.
He's
I'm
tricking
not
you.
worried about them telling you what was on it because they all sucked at it. So
Don't put. I'm just kidding.
Don't listen to us. We're stupid.
Continuity.
Cotton.
Continuity.
I don't kind of understand.
It's not. There's not
Yeah,
much
how
to
do you
it.
actually spell that?
I don't know. Yeah, I'm always right. Continuity.
No, what do you spell? It's so weird.
Continuity. That's how it is.
I want a Dutch bro.
You know what it is and math.
I'm getting discos tonight
For what?
because Sal's going to.
So, what do you want to talk about? The homework problems?
No.
No?
19 and 20.
Just do all the homework problems, please.
Okay, let's not start with 19. Let's not start with 19. Let's start with like 11. Or,
11.
I don't even remember those.
It was 19,
22.
24, 25, and 16.
Well, the day before,
Oh,
like,
yes, yes.
we have 2 days.
7, 15,
1,
20, no, that
4,
one.
10, 11, 13, 14.
Yes.
Start with 13.
Oh, look at the time.
Oh, score.
Imagine it. But she would be so happy if she saw it was 1 minute and 30 seconds. Tell me that.
And it was just a bunch of BS and
I know you need to watch it.
we haven't even started yet. It's just wasting bandwidth.
Oh my gosh, we're wasting time. Talking about wasting time.
Keep talking.
What do you want to start with?
We really have no time to do this.
One, just start with one.
Number 1. That's a good place to start.
Good job, Brenda.
Radio.
These stupid freaking things.
That says find the points of continuity and points of discontinuity and identify each type of discontinuity. I told you not to do that part. But identify. See that this is what bugs me. It says identify the points of continuity and the points of
And
discontinuity.
there is none.
There is. But this, if you put this problem, if you took this and moved it to the section that says explain why the given function is continuous. This is a continuous function, but there is a point of discontinuity. That's where I said I don't like that.
I don't get it.
Definition. A continuous function is a function that's continuous on every point in its domain.
Oh, this is a function of discontinuous.
-2 is not in the domain of this problem, of this function, right?
So
Yeah,
it's discontinuous, I need it too.
But it's discontinuous at -2.
Because the domain, the bottom cannot equal
So
negative.
it's continuous. Freaking, we're just going to abbreviate. Continuous. If you graph it, I mean, you can see, you can probably see it in the graph, right? I'm assuming on this one. You can see a vertical asymptote, right? You should be, are you starting to like, as you type stuff in, you kind of have a picture in your brain?
Oh.
Is that happening yet? Like a little
Like
bit?
this, like.
Only on the parabolas.
We're like,
Yeah.
so like 3x, I'm like, oh, okay.
Oops. What did I
Yeah,
do?
you're just like straight line.
Oops. Yeah, -2, boom, vertical asymptote. So it's continuous everywhere else. So you would write continuous from -infinity to -2, and then from -2 to infinity.
Hey, we did that last year.
Notice I put parentheses because I don't include -2 in my answer because it is discontinuous at x equals -2.
So what if I did like X is less than
Like, that was the cutest.
You know how to write it like this? Okay, good. So that's all number 1 is saying. What's next? Give me another one.
4.
Or
Yeah,
4 is always continuous.
Yay, I got that
There are
one.
no
Five.
points of discontinuity.
10.
Continuous.
10's good. 10's good.
we're just from
Like it's ln.
It's a button on your calculator.
I know, but like,
Natural log, log base e.
ew.
So you do ln of x plus 1, which is a continuous function because it's continuous on every point in its domain. But if you're doing this, it's only continuous when x is greater than or equal to -1, or greater than -1. You know why it's only greater than -1, not greater than or equal to? Or you could write
Because-
-1 to infinity. Because if I plug in Nick, can you do the natural log of 0?
No.
Can you do any log of 0?
No.
Can't do logs of 0, so that's why it's not continuous there. That's all this is. Okay, let's do 19 real quick.
Yeah, I attempted this and I just didn't know how to do it.
Find each point of discontinuity, and this is a no calculator, so this is awesome.
Wouldn't it be at 2?
But I forgot.
At 2, but it can't equal 2. It'd be negative
'Cause if
infinity
nothing
to 2
equals
and then 2 to
2.
infinity.
Yeah, you're right. You look at these first and you go,
And they're
okay,
flipped.
if I plug in stuff for x, I can plug in anything. If I plug in stuff for x, I can plug in anything. So these aren't going to cause a discontinuity. There's no fraction where x is going to be 0 on the bottom. There's no square roots. There's no logs, right? But you look here, and this is only when x is less than 2, and this is only when x is greater than 2. So where's the discontinuity? gonna be?
Negative infinity to 2. And
At 2.
Oh, dang it.
So discontinuous
Oh, the discont...
at x equals 2, because neither one of those includes 2.
Looks like disc at X.
And it says,
Right.
is it removable or not removable? Well, we'll check. And we'll see what's happening to this side. Like when x is 2, this one would be what? 3 minus 2 is 1?
So, at the 3.
What?
1. Puzzle. So, if I plug in 2. So this one's getting, something's happening, it's coming down, and it's going to 1, right? Well, this one, plug in 2 plus 2. 2 over 2 is 1. 1 plus 1 is
2.
2. So this one's up here. Since on either side they approach something different, that's not removable. It's only removable if it's like, it looks continuous, but there's a hole in it. And they both
Okay.
approach the same
So
thing.
they're like
from either
separate?
side.
Oh, they're not in the
So if they're
same
separate,
spot.
they're not removable.
Yeah, so this one is not removable. And we'll look more at removable tomorrow because that's all we have. Because I don't want to wait in line for